I'm Anil Kumar and let us explore rate of change in rational functions. So I've taken up a parent rational function 1 over x to discuss. Question here is estimate the slope of tangent to the graph of function f of x equals to 1 over x at the points x equals to -2, -1, 0, 1 and 2. So whenever you have multiple points where we need to find the slope of the tangent line, we prefer to use quotient difference method, right? So instantaneous rate of change is given as f of x plus h minus f of x divided by x plus h minus x, which is h, where h is very small as compared to 1. At times we also write this as h approaches 0, kind of, right? So those of you who have done limits, they will write limit of h approaching 0. So all these nomenclatures are being used, right? But all are correct. Anyway, let us understand what is x plus h. This is our very first function on rational functions, a parent function 1 over x, or reciprocal function. Now when we say x plus h, it means x has to be replaced by x plus h. So f of x plus h in this case will be 1 over x plus h minus f of x is 1 over x, correct, divided by h. Now, so we can now simplify by taking common denominators. So we have a common denominator, x times x plus h, right? So x plus h times x, I can write like this also. Cross multiply, so we get x minus. Always write this in bracket, x plus h. Sometimes, because when you open, this has to become negative. If you write straight, you may get it wrong. Over h. So that is how it is. Now, we can kind of simplify it. So we have x minus x is 0. And when you open, you get minus h, right? So we have minus h in the numerator. And this thing comes in the denominator, x plus h times x. We already have is divided by h. So h could be written here also, right? So at this stage, we can cancel out h. Now, since we have cancelled out h, and we know h is very small, right? Since we know that h approaches 0, it is very small, we can estimate this instantaneous rate of change as equal to -1 over x squared, x plus 0 times x, which is x squared. You see that? So that is, in general, the instantaneous rate of change for 1 over x at any given point, right? So now we know that instantaneous rate of change for f of x equals to 1 over x is -1 over x squared, correct? That is what we know. Now we need to find slope of the tangent line on this graph at different points. So let's begin with x equals to -2. So at x equals to -2, we'll substitute -2 here. It is going to be, let me write rate of change will be, we could also write rate of change at x equals to -2. This is another nomenclature. We'll write -1 over -2 whole square, which is -1 over 4, correct? Now at x equals to -1, I'll substitute -1 here. So that will be equal to -1 over -1 whole square, which is -1. At x equals to 0, I'll substitute 0 here. So I have -1 over 0 square is 0, which is undefined. Do you see that? And that was expected since we have a vertical asymptote at x equals to 0. So it has to be undefined, right? Now at x equals to 1, I'll substitute 1 here. So I get -1 over 1, which is -1. And at x equals to 2, I'll substitute 2 here. -1 over 2 square, which is -1 over 4, right? So we get all our answers. So at x equals to -2, it is -1 over 4. At x equals to -1, -1. 0 undefined. At 1, it is -1. At 2, it is -1 over 4, right? So you can see rate of change for this function 1 over x is always negative, correct? That's very important to understand from here. The graph of this function is kind of like this. right? So it is always decreasing. The function is always decreasing, and that is kind of a vertical asymptote. So where you cannot find the rate of change. Therefore, we got at x equals to 0, it is undefined, right? So at 0, it is undefined. And from symmetry, you can see, if you draw a graph, it's symmetrical. Minus 1 over 4, minus 1, minus 1, minus 1 over 4, correct? So at these points, we draw a tangent line. It'll give you a slope of minus 1, and there'll be parallel lines, correct? 1 over x is also a odd function, right? Symmetric about origin, so it was expected to get these kinds of results. I hope with this you understand that difference quotient is an excellent method to use, especially when you need to find slope of tangent line at many points, more than one, right? I hope you appreciate it. Thank you and all the best.